Okay, Module 6 is about first law of thermodynamics, but we will cover about the specific heat. And the course outcome is the ability to acquire and explain the basic concepts in thermodynamics. By the end of this chapter, students should be able to explain, to define the specific heat at constant volume and specific heat at constant pressure. So you need to be able to identify what's the difference between both of these. Okay, relate the specific heat to the calculation of the changes in internal energy and enthalpy of ideal gases, and describe incompressible substances and determine the changes in their internal energy and enthalpy. And finally, solve energy balance problems for closed systems that involve heat and work interactions for general pure substances, ideal gases, and incompressible substances. Okay, the content for this module is only about the specific heat. Okay, but bear in mind that it's a long journey for specific heat. It involve a lot of derivations. Okay. In terms of a lot of conditions. Okay, specific heat at constant volume, we put it as CV. Okay, constant volume, so we put it as CV. Both are specific heat. Okay, but this one is CV is at constant volume, CP is at constant pressure. So what does it mean? CV is the energy required to raise the temperature of the unit mass of a substance by 1 degree as the volume is maintained constant. So that's the difference. Okay, when the volume constant, the specific heat at constant volume, we have the same definition, but this one is at the same at the constant pressure. Okay, it's just the same. Okay, specific heat is the energy required to raise the temperature of a unit mass in substance by 1 degree in a specified way. But for CP is for constant pressure, CV is for constant volume. So this is the how does it relate? Okay, so if it's 5 kilojoule per kilogram per degree Celsius. Okay, this is when we this is the value of specific heat. Okay, by the increment of 1 kilogram by increment of 1 degree Celsius. Okay, so when the V constant, therefore we have different values. CV is equal to 3.12. This is the unit is the same, right? Okay, but the values are different. Okay, when V is constant, CV is 3.12. When P is constant, CP is 5.19. Okay, at different condition, we have different specific heat. The equations in the figure are valid for any substance undergoing any process. CV and CP are properties. We have values for CV and CP. Okay, and we can also find it in the table. CV is related to the changes in internal energy and CP to the changes in enthalpy. Okay, this one is interesting. Okay, you have to remember this. Okay, changes, if the internal energy changes, it will change the value of CV, and if we have changes in enthalpy, we have changes in CP. A common unit for specific heat is kilojoule per kilogram per degree Celsius, or in terms of Kelvin. Are these units identical? Okay, that's the question for you. Okay, so okay, this is the example of different values of temperature. Okay, specific heat of a substance changes with temperature. So at 300 Kelvin, this is the value of specific heat. At 1000 Kelvin, this is the value of specific heat. Okay, so CP is always greater than CV. Why? Or is it true or false? Okay, so let's say CV is delta U over dt, and it's changes of internal energy with temperature at constant volume. So this is formal definition of CV and CP. So you remember CV is changes of internal energy. So you have equations of delta U over dt, temperature, right? Okay, with temperature at constant volume. Okay, so CP is changes of enthalpy over dt. Okay, temperature, enthalpy over temperature at here. So that's the difference between CV and CP.